Hi guys, this is your video for compound and simple interest. We're going to talk about simple interest first. Probably if you think back to an earlier grade level, you probably learned the formula I equals PRT, where if you can find the interest if you know the principal times the rate, but the rate is usually a percent that we convert to a decimal, times the time. Okay, so interest equals principal times rate times time. Okay, so, but that only gives you the interest. The formula that we're going to use gives us principal times rate times time. So this is the same thing right here. Okay, but it adds on the principal. So what this actually gives us is the total balance. So this just takes our I equals PRT formula a step further. And it looks a little bit different because instead of just saying P for principal, they say P sub 0. And anything sub 0 means the starting amount. Okay, so it takes the interest, it's basically the principal plus the interest equals your total balance. Alright, so we're not going to be using that formula at all, but I put it in the notes and I'm putting it in the video because it's something that you can relate to, it's something you've seen before. Sarah has $400 that she deposits in a simple interest account. So $400 is my P sub 0. The interest rate is 7%. That's my R. However, I have to convert that to a decimal by moving the decimal point over 2 times. We do not use percents in mathematical formulas. So now we can sub in. P sub t, or P of t, equals 400 plus 400 times 0.07 in parentheses times t. Okay, then we're going to take that value or that problem, that multiplication problem in parentheses, and we can actually multiply that out and simplify it. Okay, so it's going to be 400 plus, let's see, 400 times 0.07 is 28, and then bring down the t. So P of t equals her $400 initial investment plus 28t. Okay. Warren has $300 that he deposits in a simple interest account. Alright, so same idea, except this time our initial amount or our principal is $300 plus 300 times, again, we got to move that decimal over. This is our P initial, this is our R. Move it over 2 times 0.075 times t. So if I multiply these together, I get 22.5 t. Okay, let's look at these equations for a second. What type of equations are they? Well, we've got a constant plus a coefficient with a variable. If I switch these around to be P of t equals 28t plus 400, would that be an mx plus b? So these are linear. Okay, how much will be in their accounts after 2 years? Well, 2 years is a unit of time. So I'm going to take these formulas and I'm going to sub in 2. So 400 plus 28 times 2 is $456. Okay, if we did the same thing for Warren, P of 2 would equal 300 plus 22.5 times 2. That's $345. After 10 years, same idea. We're going to sub that in for T. So P of 10 would be $680. Okay. P of 10, 300 plus 22.5 times 10. We're just subbing in 10 for T. $525. Okay, just typing this into the calculator or doing it in your head. Either way. Okay. Some of your homework problems are going to ask you to figure out how long it takes them to get to a certain amount of money. So that means if my formula is P of T equals 400 plus 28T, this is $2,000. That's not a unit of time. I'm not subbing that in for T. I'm subbing that in for P of T. And then I'm going to solve. It's a basic two-step. Now this is not going to come out perfect. Okay, we have 1,600 divided by 28. Now, it says 57.142. However, rules of rounding would seem to make us round down. But if we round down, we won't make it to 2,000. It'll be under 2,000. So we're going to want to round that up. If we rounded to the nearest tenth, that would be 57.2. If we rounded to the nearest whole year, that would be 58 years. Okay, again, rules of rounding seems like we should round down to 57, but we won't make it to 2,000 if we round down. Okay. If we go over here and we talk about when Warren is going to make it to 2,000, same thing. Take our formula, sub in 2,000 for P of T, and then solve it. Here again, we need to round against, well, this one actually does not round against the rules of rounding. T is either 76 years, or if we round to the nearest tenth, 75.6 years. Okay. We have to round up either way. Alright, another question that your homework is going to ask, it's the same question, but they're asking it in a different way. It says, how long will it take to double their initial investment? Well, you have to remember and be able to pick that number out of the formula. Alright, so if my formula is P of T equals 400 plus 28T, okay, the initial investment is the principal, that $400. If I double that, that's $800. So 800 is what I'm subbing in. And I'm figuring out how long it takes to get to 800. So again, basic two-step. And again, we're going to get something that's not going to come out pretty. It's going to come out a decimal. Okay, so T is going to have to be at least 15 years to double, because 14 would not be enough. Okay, you could say 14.3 if you wanted. Let's look at Warren. So doubling, his original formula is P of T equals 300 plus 22.5 T. His initial investment was $300. So if I double that, we're talking 600. Subtract 300 each side. Divide by 22.5. And I get 14 years. Okay, but in real life, simple interest is really not how banks do business. They use something called compound interest. So in compound interest, I'm going to start off explaining it with a simple chart. Okay. Year, the amount of money. Let's say you start out with $100. Okay. And let's say the account is earning 5% interest. So that means we're going to use 0.05 for our decimal. So $100 times 0.05 would equal $5 in interest. So that's how much interest I would earn. And I would add that to my 100 so that at the end of the year I would have $105. Okay, here's the difference between simple interest and compound interest. In compound interest, that $5 that I just earned and added in, that now earns interest. So instead of 100 times 0.05 again, instead of adding $5 interest every time, I'm going to calculate a new interest times 0.05. And it comes out $5.25. So now I made more interest this time. It's not just $5, I've made 25 cents more than that, which I add on to this. So 2 years, that would be $110.25. Okay, so now I have even more money that I'm going to get 5% for. So 110.25 times 0.05, and I get 551. Every year I'm making more interest, and that means I'm getting more and more money. Okay, so compound interest means you earn interest on your interest. Simple interest, you do not earn interest on your interest. Okay, it also means this relationship is not linear, because if it was linear, I'd just go up by $5 every time, and I don't. I'm going up by more every time. Okay, so here's the formula for compound interest. It has a lot of the same letters in it. All right, P of T is going to represent your balance, how much money you have. P sub 0 still represents your principal. R still represents your rate, but remember that's a percent that you have to convert to a decimal. And T still stands for time. Okay. So Sarah has same $400. In fact, we're going to do all the same problems again, except we're going to use the compound interest formula instead of the simple interest formula. So P of T equals our initial investment, $400 principal, times 1 plus 7%, 0.07 to the T power. Here again, there's some work inside the parentheses that I can evaluate, I can simplify. Okay, so P of t equals 400 times 1.07 to the t power. I just added those values in parentheses together. Once they're added together, I don't need the parentheses anymore. Okay, Warren has $300, so same thing, we're just practicing it one more time. Compound formula means the money you start with times parenthesis 1 plus 0.075 to the t power. Remember, we moved this decimal over 2 times, 0.075. And we can add these two values together and simplify this at least a little bit. 1.075 to the t power. Now, can we multiply these two values together, 300 and 1.075 to the t power? No, we cannot. We cannot do that because this does not have an exponent and this does. In fact, if you're going to simplify things in a shortcutty way, you either have to have the same exponents or you have to have the same bases. And we don't have either of those things. So that's as simplified as we can get. Order of operations says we can do parentheses. Okay, yep, we could do the parentheses. Then exponents. I can't evaluate an exponent if I don't know it. So I can't do the and then if I can't evaluate the exponent, then I can't multiply, because multiply comes after exponents in order of operations. Okay, so what types of functions are these? We already said they're not linear. Okay, when we go to type into this into the calculator, into our y equals, t will be replaced by the letter x. Okay, so when x is an exponent, the functions are exponential. These are going to be exponential functions. In fact, chapter 5 is all about exponential functions. Alright, how much will be in their account after 2 years? Here again, we're just going to type in or write down P of 2 equals 400 times 1.07 to the 2 power. So I'm just going to type that in. 400 times, I got to be really careful and watch this calculator because it's typing in extra values, 1.07 to the 2 power. Okay, 457.96. Okay, all right, the next one says after 10 years. So 400 times 1.07 to the 10th power. Second entry, remember you can do that. I'm going to make that a 10. Enter. 786.86. Okay, if we do for this same thing for Warren, P of 2 equals 300 times 1.075 to the 2nd power. $346.69. And P of 10 for 10 years. We'll just second enter. Make that a 10. 618.31. Okay, so just subbing in. Okay, how long will it take for each of them to reach 2,000? All right, guys, listen, we don't have algebra enough. You don't learn how to really do this to get an exact answer until you take Algebra 2 trig, because you need something called logarithms to do this. Okay, so P of t equals 400, we'll do Sarah's first, 400 times 1.07 to the t power. So this time 2,000 is not a unit of time, it is a unit of money. So we're subbing that in for P of t. Now, I can't just work my way backwards through order of operations to get t by itself. Okay, this requires logarithms. So we're going to use our calculator to figure this out. Go to your y equals and put in 400 times 1.07 caret x. Then go to the table, except I'm going to start my table at 0. Okay, if you start at 0, what you're looking for is when on this side, when on the y side does it get to 2,000? And you're going to just have to scroll. And I've got to be careful because the on-computer calculator runs away with itself. And I know when it is, so I'm trying to go slow here. Okay, I can see it. So it hits that value of 2,000 right here. Okay, between 23 and 24 years. Let me blow this up. 23 and 24 years, you can see that at 23 years it was $1,896 and 20-some cents. And at 24 years, we're over the 2,000. So we can't see the exact time that it hits $2,000 without knowing how to do logarithms. But we can say that it will be between 23 and 24 years. And if I was doing this for, let me do the double investment. Well, I have Sarah's formula in here. I'll do both of Sarah's at the same time. Double the investment means 800 equals 400 times 1.07 to the t power. Here again, I can't solve algebraically without logarithms, so we're going to just use the calculator. Oh, except that after a point, yeah, I can only scroll on the x side. Oh, there we are. Okay, so between 10 and 11 is when we're going to make it to $800. Okay, if we were doing Warren, he would get $2,000. His principal is 300 times 1.075 to the t power. So now we're going to go into the calculator again. Go into your y equals. Clear this one out. 300 times 1.075 caret x. And we're going to scroll till we find 2,000. Okay, here it is. It's between 26 and 27 years when it's going to reach 2,000. When will he double his investment? Well, his original investment was 300. Double it would be 600. Okay, guys, really important on your homework assignment that you write down this step right here and right here. It shows that you understand what you're looking for. And I can't see what you're putting in the calculator. So if all you write is between 10 and 11 years, I don't know why you put that answer. unless you write down the formula. So make sure you write that. Okay, so we're looking for $600. I'm going to have to scroll up. Oh, there it is. Okay, so 600 is going to be between 9 and 10 years. So you can only do this on your graphing calculator using your table function. Okay. The last part of your homework assignment is going to ask you to take the linear and compound interest formulas for the same situation and compare them. So let's do that with Sarah and Warren. Sarah's linear simple interest was 400 plus 28t. Her compound interest is 400 times 1.07 to the t power. And the units of this is going to be money. So now I'll go into my y equals. And I'm going to put in both equations. I'm going to put the linear one in first, simple interest first, plus 28x. Then I'm going to go down and type in the compound interest one. I'm going to have both of them in there at the same time. Okay. And I want my table to start at 0. Okay. So now I can use this to find out all my other values. So 0 is 400. Now that's, no matter how you're calculating your interest, you start out with $400 no matter which formula you're using. Then it wants you to look at row 3. Row 3 is $484 for simple interest and $490 for compound interest. Okay, row 10, 680, 786.86. Okay, it looks like compound interest, I think some of you are probably pretty glad right now that you use compound interest for savings accounts and so forth. Maybe not so much for loans, because that means you're going to pay, loans back at a high rate. Now, I need to show you something when we go down to 20. Okay, so row 20, 960 for 20 years. It looks like this says 1547.9. Oh, Mrs. Andrews, it's money. Put a 0 after it. Well, yes, except that, watch what happens when I arrow over. Do you see what's written underneath here? Okay, it's not really 1547.9. The calculator has rounded. So it's actually $1,547.87. So make sure you arrow over and have it show you what number specifically is in there, because you get a more accurate value that way. If this was a Regents exam and you put 90 instead of 87, you get marked off for that. So be careful with that. Okay, let's do the same thing with Warren's equations. So Warren's equations were P of t equals 300 plus 22.5t. And his compound interest was 300 times 1.075 to the t power. So those units, money, time. I don't even think that's necessary because it already says time there. You don't need to put anything in these boxes. Expression, 300 plus 22.5t, and 300 times 1.075 to the t power. So put both of those in our y equals. Okay, I'm also going to start my table back over at 0. The table start leaves off where you do. So if I want 0 to start with, I'm going to want to restart my table. So I went to second and window, which has table set above it, and that'll put my table set back to 0. Okay, so at 0, doesn't matter, 0 is the amount of money you start with. It doesn't matter which formula you're using, you're starting with the same amount either way. Okay. For after 3 years, we're going to have $367.50, or we're going to have $372.69. 10 years, $525, or $618.31. 20 years, gotta scroll. Okay, 750, simple interest doesn't make those big decimals. But we have to scroll over. Don't write 1,274.40 because that's not the exact value. $1,274.36. So make sure you're scrolling over so you can see this value all written out and not abbreviated. Okay, so what's the difference between simple and compound interest? Well, the difference is compound interest earns more money. Because, whoa, too far. It grows at an ever increasing, that's an R. I don't think it looks like an R the way I wrote it. Ever increasing rate. Okay, in simple interest, you are not earning interest on your interest. In compound interest, you are earning interest on your interest. So you're getting more and more and more and more money. Okay? All right. See you next time.